All right. And today's what we're doing there today is we're just introducing the course, the syllabus, that kind of stuff, and we're going to hit exercise 1.1. Generally, you know, the textbook is very expensive. All right, and if you have the textbook, that's good. If you don't have the textbook, the course is pretty much self-contained. We'll go through, if you guys have already seen what we're into there for week 1, you'll see there that I'm big on giving you guys questions and answers. Okay? Y'all paid your big bucks, man. You know what I mean? What am I going to do? Withhold the answers? So, you guys are adults. You guys meet people there. I see Facebook and Insta and all that kind of meet and greet. Get some type of a team going. If you know what I mean, this is your second semester. I'm sure there's probably some familiar names in here to you. And if there's not, we can set up something, okay? Because there is a huge opportunity for social learning here. And you guys need to bounce ideas off someone else other than me. I am always available, but you know what I mean? Let me know what's going on. Keep me in the loop. And other than that, it's open mic. Do you guys have any questions there? Any emergencies? Oh, well, talk to me, Melissa. What do you got?
Hello.
Hello.
I was just wondering, I ended up purchasing my book online, and just for that short term until the semester is over. Are you going to be using a lot of references from the book, or do you think because we've taken the course already, I can kind of not have to pay the $90?
Yeah, how much is the e version for the semester?
I think it was $90. I don't remember, but I know it's expired now for me. So
this book is $90. Eggs are $3 a carton, man. What's next? You know, honestly, I can't say not get the textbook. The textbook will ensure, you know, wholeness and pure and total understanding. But, you know, I've taught this course there a couple times, and it's pretty much self-contained. You should be okay. Like, the two greatest inventions in your generation, Google and YouTube. So, you know what I mean? The whole world, every second of it is being recorded as we speak. So, and there's so much information out there in statistics. Like, this course here is not going to be the one that takes you down there this semester. I'll let the chemistry, I'll let the bio. Those are the two brutes there this semester. I know it. I just taught them. All right? And you guys can focus on those. Don't leave this one, but this one here is not going to be as taxing as as your bio for sure. Hopefully you guys are enjoying that bio and chem. If you're not, you better start because you guys are in health. And the bio there, you guys are going to like it. Every week it's a different organ system. Bang, 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 bang. So if you guys are having any issues there with that one, anything else, just let me know, okay? Good question, though. Thank you, Melissa. Anything else we got? No, Ian? Shut up, Ian. Let's get this over with, Ian. Sounds good.
Sorry, I have a question.
Oh, hi, Riley. What's going on?
So when I looked on Blackboard yesterday for today's lesson, I couldn't find a PowerPoint. I just wanted to know, like, is there a PowerPoint? Or
Yeah. Is there any issues? Go to weekly.
Yeah, it just didn't. I don't know if it just didn't show up.
This is what I needed to know. Weekly.
Wow.
Week 1?
Yeah.
You see it there?
Yeah, I have it open.
All right. Well, no, that makes me good. That makes me happy. And please don't ever be afraid to ask a question, or maybe you think your question is, you know, in my class, the number one priority is getting the information to you. Okay? And if something is stopping that information from getting to you, whether you know, Blackboard or anything that I can solve, please let me know. Okay? this is my fourth semester doing VR, and we're getting the hang of it, but we're still dealing with a system that can do things on its own. Okay, so if you ever see anything funny, something doesn't make sense, just shoot me an email. You know what I mean? And we get it sorted out. Another rule, and this one here is very importante. The questions there that I give you at the for every week, there's questions and answers, this and that. When you guys, they come from the textbook there as well. If you ever solving a question and you're not getting the answer that's in the back of the book or the answer there that I give you, do it twice. And if you still don't get the answer, shoot me an email. You know what I mean? I really love the initiative. I've had students there in the past that, I stayed up till 4 o'clock in the morning trying to finish number 39 on page 157, and I couldn't get it. Well, I go, don't do that. Do it twice. Email me. I'll check. I'll do it. And as it turns out, there was an error in the back of the book. Like these textbooks, man, they pay PhDs thousands of dollars to review them, but they don't. They don't do a great job. So if something's not making any sense, do it twice and then get a hold of me. Okay? And don't waste your time, waste mine. All right? And because, you guys have got enough on the go there this semester. I think you guys are doing, 6 courses? Whew. You guys are going to be busier than a cat in an ash pile, as my grandmother would say. But you know what? Get on it. You guys are good. Good questions. What else we got? Anything else? If not, I will continue with the syllabus. The syllabus is online. You guys can, I think it's an important stuff there on the left-hand side. Sorry, I'm just setting up a screen share here. And, come on. There we go. So, here's the syllabus. There's the course outline that's also there. You know what I mean? That's just the objectives that you're going to learn, right? What you really want to know is this syllabus right here. There's my contact. This is the WebEx room that you're currently in now, but I'll post that once or twice a week anyway, so you don't have to go back here to refer to it, okay? There's my information. There's my email. I check my emails like 10 times a day, so email me with any issue that you see. Usually Friday afternoons at around 2, I sign off and then I pop my head up back again there Sunday afternoons. That's generally my thing. If there's any emergencies though, I do maybe sneak a peek Saturday morning. All right. Week 1, this is what we're doing right here. Just an intro to stats. That's all it is. Grouping, how do we do sampling and all these kinds of things. Actually, what is a sample? And some of this stuff is not going to seem very interesting. I promise you. But where you guys are going, you guys are going to be reading journal articles. You're going to be reading papers that all have statistics in it. And yeah, we all know mean, median, mode. And we do that for a week or so. But there's a lot of other things there that encompass this. And this is important stuff. And especially in a day and age of, pandemic, right? We have morbidity rates. What is a morbidity rate? You've got child mortality. You've got all these different rates going on. Where, Italy as compared to Canada, and, how can you compare a country like India and their COVID rate? How can you compare it to a country like Canada or, England or, Thailand? They all have different populations. But we're going to figure out this. We're going to figure out how to compare them and make all of this scientifically possible. Because that's what this is. We're in the business of science. And science doesn't care about what you think, doesn't care about opinion. It only cares about truth and fact. And just the whole idea of, we'll get into more when I get into the PowerPoint there. You'll see here that your first assignment will pop up there next week. You'll have 2 weeks to do it. Generally, that's how things go. Okay. There's an assignment 1. Okay. And then there's a case study, which is just another word for an assignment, but it's more focused. And then there's assignment 2. Okay. I'll show you a little roundup here. There are 3 quizzes. Okay, and you'll have a week to do those. And then on weeks 4, 9, and 13, there's 3 tests. Okay, so this course is pretty decent. It's not here to tax you that badly. Okay, does that mean it's just gonna come naturally? Some of it is not. All right, but it's an interesting course, and the things that we're talking about, this is going to be more of a society course with a bit of math. And we're going to be understanding society. And that's what statistics are. You talk about population. Is it the population of Canada we're talking about? Or is it the population of a province we're talking about? Or is it the population of a city or a county? What about a neighborhood? We can even go household. And lastly, you can take it down to the individual. So there are different, you'll see what I'm talking about when we get all through this, all right? Here's this little snapshot in a nutshell, okay? There are your 3 tests, 60%. There are 3 quizzes at 15, which is 555. Assignment 1 and 2 is 8 and 8, and case studies there is 9. So that's what we're looking at there. It's a good course. All right, and it should be fun, it should be interesting, and absolutely applicable to where you guys are going, okay? Any questions? How we doing?
I have a question.
All right, let me see who I am talking to here. Who's talking?
Madeline.
Hi, Madeline, how are you?
Good, how are you?
Surviving.
Same here. I just have a question about the due date. So for all of our assignments and quizzes and everything, are they always going to be due on Thursdays by 11 like last time? Or are they going to be due like Thursdays at midnight?
Yeah, you see, that's the issue, right? And I haven't figured it all out yet. Whatever it is, I'm thinking they're midnight. But, on the days like you have tests, like let's go back to the syllabus here. That's a good question. Thank you for that. And you have a look here. Come on, don't freeze on me. So you look here for test 1. Like quiz 1 is due there is on Blackboard there the week before. And if I have this quiz open till midnight, then you've got a quiz and a test going on at the same time. So I don't know. It would probably make sense to have everything due before class. And but whatever it is, it'll be consistent for everything, and I'll let you guys know there next week. So good question. Thank you.
No problem. Thank you.
All right, I'll keep that in mind for sure. What else we got? Anybody got any questions? Come on. Nothing? All right, let's go.
Question.
Oh, hello.
Sorry. I'm just wondering if the tests are cumulative or if they're just on from weeks 1 to 3 will be on week 4 test, week 5, or is it the whole what we've learned?
That is an excellent question. Love it. As these tests here, this test here for test 1 will revolve around the main, that's all there is there. But for test 2, it's going to revolve around everything since test 1. But I can't say that there won't be anything from test 1 on test 2. Because with mathematics, there is a bit of accumulation as you progress through it. So generally the tests are going to focus on the previous couple of weeks, but that doesn't mean that there couldn't be something because you cannot do the stuff in week 10, 11, 12 until you've done weeks 1 to 6. So there is a bit of an accumulation there, but generally before every test, I'll let you guys know exactly what's going on. Okay, Cheryl?
I have a question.
Yes, Melissa.
I'll have lots of questions this whole semester. To give you a heads up.
Very good.
I'm that student. The reading week obviously is not March 8th to the 12th, but is there going to be a break between the weeks 6 and 7 in the syllabus?
Isn't that? Oh yeah. Sorry, I guess that should be that. Yeah. There. Oh yeah. There's a
June 28th to July.
Sorry. Yeah. Yeah. That's the last week in June, I think, isn't it?
Yeah, the 28th is the Monday to the Friday, which is July 2nd.
Yeah. So, and it's in between week 6 and 7. And,
okay, so we do have that week off.
Yeah. I'll update that there before the day's over. So good question. What other? You said you had lots of questions. I like it.
Oh, I'll have questions all semester.
Good. And you know what? That's how this course works, because there is this separation distance between us, right? I can't see you guys on a weekly basis and keep tabs on you like that. So please, if anything is, if a question is bothering you, or a chapter's bothering you, or, I'm bothering you. Well, I don't know what I can do about that. But if you anticipate, someone's got their brother's wedding or something like that, and during, some other time there, let me know, keep me in the loop. Please don't let me know the day before a test, you know what I mean? But if emergencies happen, we're all trying to survive here. I got 2 kids at home. I'm sure most of you guys have kids at home, or, we've got all these different situations here. So, we're all just, you guys are fighting. We're all just trying to get along, and we're going to get you guys through, and get you guys through with good marks, get you guys out of here. So that's my plan. What else we got? We're good? Let's go. Where is that now? Week 1. Perfect. So I am recording this. If you got a jet, you know what I mean? If there's any issues or whatever, I'll post this there to YouTube as soon as we're done, and y'all can watch it as many times as you want, okay? All right. So here we go. Attendance, not mandatory. Videos will be posted. Everything, quizzes, assignments, all these kinds of things, they have a strict guideline, but if there's any issues there, just refer to the syllabus or me, okay? Blackboard, I think you guys are probably better than me at Blackboard right now, okay? So if there's any issues, just keep me posted. We've gone over the syllabus. We've broken down the tests. The tests are good. I'm still working on leeway and all these kinds of things, how much time we're going to have. I like to have a little bit of open time, but during the test times, there is no class. So, you know what I mean? There's no class on week 4, there's no class on week 9, and there's no class on week 13. So we just might have our tests during class time from 11 till 2. And but more details will come as we get it all going. Okay. What else we got here? The homework questions. Okay, they're posted as well in the folder. Okay. So you have your questions here. All right. And the answers are all here as well. Okay, so these are the answers. You guys have copies of those. The questions are there. Okay, and these are not multiple choice there this week. These are all different types of, if you read it here, we're talking about sampling methods and identifying which sampling method, and you guys will see the PowerPoint there, but the answers are all there. Make it make sense, and if something doesn't make sense, make sure you get a hold of me, okay? All right, overview of data, okay? This is what we're talking about. Data and its collection, okay? the whole point of this is we're trying to maintain some type of scientific standard. And that's what we want to maintain throughout all this, okay? So statistics is a branch of mathematics and science that helps researchers to develop a set of procedures to collect, organize, present, analyze, and interpret data for the purpose of drawing conclusions, making a decision. So basically, in a nutshell, what we're doing is we're taking mashed potatoes and organizing them and making them into French fries and ordering them from the smallest French fry to the largest. You know what I mean? So we've taken all this chaos and we collect it, we organize it in a scientific fashion that suits our needs. Now, you're going to find out that statistics is kind of like a two-sided coin. Well, I guess all coins are two-sided, so let's just call it a coin, shall we? And you can look at a coin from this side and you get this idea. Well, what happens if I look at a coin from the other side? Well, there's another picture over there. Okay, two sides of the same coin. Welcome to statistics. Politicians and the political system, they are mass users of statistics and being able to spin things to make it look like it's good or bad in either way they want. So you're going to see some ambiguity, and that's good. That's good. You're going to see, this is, well, let's see what we get here. So, uses in health sciences to learn about overall health trends. And so much in a pandemic, trends are so important. Weekly trends, even daily trends. Geographical trends. Okay, to weigh the potential risks and benefits of a particular medical treatment. Sure, like the AstraZeneca vaccine there. What? Statistics told us that 1 in 55,000 people would get a bad blood clot. You know what I mean? Where did that number come from? Well, they had to crunch the numbers. They had to do statistics, okay? To provide important information to patients about medical procedures, sure, and to analyze costs associated. Sure, there's the whole cost thing, right? If you don't got the money, you can't run a hospital. Stats can be broken up into two different areas. We have descriptive statistics and inferential. Okay? And descriptive statistics deals with the organization, presentation, and summary of this raw data. And what you're doing is you're reorganizing it into some type of, graphs are so good because, the whole adage there, a picture says 1,000 words, right? And if you have a graph that is indicating something like this, whoosh, that's telling you something, right? Inferential statistics. This is where we take a sample drawn from a larger population to deduct meaningful conclusions that we can apply to the entire population. Let me say that again. You have a population, right? And if I want to survey everybody in this population, well, it's going to cost a lot of money. So why don't I just survey a sample of the population, as long as it's done properly, and if done well, I can actually project the results of this sample onto the whole population, right? So it's called inferring something, right? So here we've got describing statistics and inferring statistics. And this unit, probably next one as well, it's going to be a lot of throwing words at the wall, and hopefully some of them stick. And so that, by week 2 and week 3, these words will become commonplace. So that's what we're looking for here. So here we've got population, sample, attribute, variable, a parameter, and statistic. Okay? We're going to go over these right now. Population refers to a set of all possible individuals, objects, or measurements of interest. So it just means everything that you're looking to study. Okay, an example, all students enrolled in a post-secondary health science program in Canada. Right? A sample, though, refers to a smaller group which was drawn from that population. Okay, so here's your population there, too much money. Let's randomly choose some people here, and now we have a sample. All right, so example, 200 students drawn from the post-secondary health sciences students population. So here we have thousands, here we have 6. Well, here we have 200, okay? There's 6 here. I don't know why they're saying 200. There we go. Oh, and by the way, this is a democratic classroom. If you have a question, just turn your mic on and ask. It's all good, okay? Attribute refers to the characteristic of the data that can be observed. So an example of an attribute, just another word for an idea, age, income, gender, blood type, these kinds of things. Okay, that's what we call an attribute. Variable represents the value of the attribute. So age would be 20 years old, years. Okay, income, dollars, $40,000. Gender, female. Blood type, okay. So these two are tied together here. Parameter refers to the value that summarizes a certain variable for an entire population. We'll get more into these here. These mean something that you can project upon a population, like the mean. And the easiest example there for a mean is I tell you there the class average was 75. So that means there that 50% of the population got above 75, 50% got below 75. So the mean is the middle. Okay? We'll show you guys all this. Standard deviation is the spread of the population. So if your mean was 75, the class average was 75, and everybody got in between 70 and 90, the whole class would be around here, right around the mean. But if we had a very dispersed population, we had a lot of people who failed, some people there got 40s, 50s, 60s, you know what I mean? It would be more spread out. This is called standard deviation. And all of these are applicable, but we'll get there. Okay, I'm just throwing words at you, probably confusing you more than anything, but it's all right. Okay. Statistic refers to a value that summarizes a certain variable of a sample. So you can have the mean, the class average, for all pre-health students across the province, or we can just deal with the mean of the pre-health students there, a small sample here at Georgian College. So you can have mean and standard deviation for an entire population. You can have the mean and standard deviation of a little sample. So lots of stuff there. And the nice thing is about these videos is you can go back and watch them again and again and again. Have a look here. A researcher is interested in determining the average annual income of family physicians in the city of Toronto. She randomly selects a sample of 50 family physicians in Toronto and uses the data gathered to estimate the average annual income for all family physicians in Toronto. Okay, so I just want you guys to know this question here, the way this course is worked, that's a typical question. All right, and I don't want the English to be a problem. And it doesn't matter if you're a native speaker or not. I taught ESL overseas in Asia and Africa for 15 years, actually longer than that. And I don't want the language to be the problem, but it can be. So don't let it. Okay? So this is what we're looking for here. You want to be able to break these questions down. Okay? So the researcher there, she wants to determine the average income there for doctors in Toronto. So she selects 50 doctors, okay, and uses the data gathered to estimate the average income for all family physicians. Okay, so this is your population here. So what is a population parameter? Okay, here, all right? And the average annual income for all family physicians in Toronto. We'll get more into this, okay? There you've got a population parameter, you have a sample statistic. So here, we're taking 50 and we're going to project it on to everybody, all right? It's going to get interesting. In inferential statistics, it is important to draw a sample from the population that is representative of the entire population, because the number one word we want to avoid is bias, okay? And remember that whole statistics, the two sides of the coin, right? Well, you can make things, you know what I mean? If your job depends on this study going your way, well, you know what I mean? Subconsciously, you might be kind of pulling it to your way, and you can't do that. Everything has to be unbiased. It has to be just and truthful, okay? And the only way that we know how to be just and truthful is to make things completely random, okay? And because in our minds, random means I have no control over what is happening, so this is what, fate has provided me. You know, if I was that person doing a sample study there of 50 doctors in Toronto, I would randomly select 50 doctors and I didn't choose them. This is random. This is valid. So the theory goes, okay? So there's randomization right there. Sampling method is randomized if every element in the population has an equal chance of being selected. Okay? That's what random is. I'm not involved in it. And as long as every option has the same chance of being chosen, then it is random. Okay? Let's go into some of these sampling methods here. Some of them are going to seem a little whacked. Let's have some fun. The truest form, okay, of randomization is this one here, the simple random sampling method. Okay, you put everyone's name in a hat. You can't see anyone's name. All the papers feel the same. You're moving them around with your hand, and there you go. You just choose, right? So drawing numbers for our names from a hat using a computerized random number generator. Okay, that's how things are done there with computers nowadays. So that's a simple random sample. But let's say if we wanted to do a random sample there of the people there of Canada, and if you look at different neighborhoods, even in Toronto, you have all these different ethnic neighborhoods around, and the nice thing about a simple random sample is, I can just pick. But the trouble is now, neighborhoods can, and that goes back to the whole idea. What population are you really trying to sample here? Like, Canada is so big, if we wanted to represent an idea of Canada, well, we have rural Canadians, we have urban Canadians, and all these type of things. So, what about, is this neighborhood going to give a different idea or have a different thought process or different opinion as opposed to this neighborhood? So maybe there's more to it than just, for this particular case, there's more to it than just random sampling. Because, you could get 5 people from this neighborhood and 1 from this neighborhood. And so now that's how your data could be skewed. And if you've got 5 people from this neighborhood and 1 person from this, and they're giving, these 5 people collectively will probably have a closer alignment of opinion, possibly, maybe not. And so we're trying to justify our actions. So if you look at this one here, stratified random sampling, maybe the researcher realizes there that, we still need to do random, to make this scientifically valid. But maybe the first time I did this here, look, we have two distinct populations within this one population. We have blue dots and green dots. You can call them whatever you want, okay? And maybe I did a random sample. What if I got 5 blues and 1 green? Is that a true representation of this population? Not even close. So stratified random sampling is where we stratify, where we separate, okay? Where we separate things into little groups. And then we random sample from those groups. And you see what we have here now? We have 3 green, 3 blue. We've done very well. And that looks like a good representation of this one here. So that's called a stratified random sample, okay? And same thing here, just goes over it again. And just the steps. Identify the particular attribute to be identified. In this case here, they're saying that this is gender, okay? And then you divide it, you stratify into their respective populations, and then you pull out through a random sample, okay? Systematic sample. This one here involves this little formula right here. It's not killer by any means, okay? A systematic sample is still random sampling, but there's a little bit of an approach here. So what we're going to do is we create a numbered list of all the elements in the population. So you put them in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the way to 1,000. Okay, so we got 1,000 bananas that we're looking at analyzing. Okay, and then you divide the number of the population there by the size of the sample to get the interval. So here, in this case here, we don't want to interview 1,000 bananas. We only want to interview 30. Okay, so what you do is you use this little formula to get K. And you take your population, which was 1,000, divide it by what you're looking to sample, which is 30, and you get this number, 33. Okay, good. Ian, what's the whole point of this? Is because now you have your sample, you have your population of 1,000 and it's ordered. What you do is you choose a number between 1 and 33. And in this case here, they just said, I'm going to choose 27. And so your starting point is 27. You're choosing 27, and then you go up 33 to 60. And then you go up 33 again. These are the bananas you're going to choose. These are the sample that you're going to choose. So you weren't involved. The formula told you to choose every 33rd because we went 1,000 divided by 30. Those are the numbers there. That's my population, 1,000. I want to choose 30 for a sample. So K is 33. Randomly choose a number between 1 and 33. Here they chose 27. That is your starting point. And then every 33rd, you pull those, and that will be from your sample. That will be for your sample. That's called systematic sampling. Okay. Now, are we really going to hit on all these? Yeah, for the first test there, definitely. But you might, we'll deal with random sampling and stratified sampling later on. I think it's week 8. All right, 9. So, no, sorry, week 7 and week 8, I think. So the tests aren't directly, cumulative, but some of the information there will carry through to the second and third test. Okay. Look at that, we're halfway through. Yeah, we should be done by about 12:15. Is it possible to achieve a seemingly randomized result without actually using a randomization? Okay, so you see, this is what we just talked about there, systematic. Okay, so you have your population, you put it all in order, you find your K value, and you find your starting point, and then you jump. And there's your sample size there, and that's how you do your study. Okay. Cluster sampling. In some populations, it's very convenient to break the population up into clusters, neighborhoods. This is a nice one. Okay. And if you have different populations that are close by, and neighborhoods are a good example, right? And you could randomly sample from all these 1, 2, 3, 4, 5 neighborhoods, but would you get a true representation? Well, just randomly sample from each of them, okay? So selecting a sample requires randomly selecting a sufficient number of these clusters and then sampling every element of the clusters together. So that's how this works, okay? Multi-stage random sampling. When a population is very large, it may be first necessary to narrow down the population into smaller groups before employing one of the sampling techniques. So you see what we're doing, it's a combination, right? Here's your pop, we'll stratify, and you can cluster them, and then you pull from all these. So that's multi-stage. It's a nice one because you look at Canada, we have people living everywhere. You know, I think is it 90% of the population lives within 500 kilometers of the U.S. border. I guess we all like warm weather. And
sorry.
hi, who am I speaking to?
Melissa.
Hi, very good. Go ahead, Melissa.
The strata, is that like the like the random selecting of each group and then selecting from that group to cluster it?
Good question. Nope, but good question. What you're doing when you where was that one here? Good question. And so stratified is before you do any random, you separate them.
Oh, okay. Like oil and water. Okay.
Yeah, perfect. Hey, man, great question. Love it. Because you got to have it straight. Cheers, Melissa. And so where was that combo, multi-stage? So,
Sorry.
oh, hello. Hi, Riley.
So you know how we like now we're clustering them?
Yeah.
What if one of the samples has like an odd number and you can't cluster them evenly? What would you do then?
You just do what you see when you're talking large numbers. One doesn't really, but you won't encounter any of that. Everything is pretty much laid out for you. Don't you worry about that. Good question though, but statistically probably not significant. And we just pull what we can pull, and you'll see here that if you look at this one right here they've got 5, 5, and 4 here. You know what I mean? So I wouldn't worry about it. Good question though. Thank you.
Okay.
And a lot of this right here is probably just going, what's he on about, man? Wait until we get some real life examples, and then you can apply these. So important, try these questions at the back, because these questions at the back are going to just ask you, here's a scenario. What do you think it is? Do you think it's clustered? Do you think it's stratified? What do you think? And you know what? Some of them there you may even disagree with. That's allowed. Anything on a test or a quiz, though, is it's pretty straightforward. All right. I think there's one or two there that I probably could do different, but generally they're all pretty good. What do we got here? Convenience sample. This one here. I like it, but not really. A convenience sample is sometimes used to collect a sample by selecting elements of the population who are readily available and willing to participate. So, yeah, I'd participate too in this experiment. Yeah, what, you're giving $1,000? Sure, man, I'm all over that. Yeah, sure, whatever you want. Yeah, you want me to say this? Yeah, sure. Do you see the problem there? Now, somebody is, and their intentions could be very honest. Their intentions couldn't be. Their intentions could be, this is a job. You're paying me $1,000 for the weekend? Sure. Now, this is, a cost-effective way because you don't have to go out and find these people will come to you. But there can be some type of bias. Hey, you. Get off my hoodie. Sorry, my beagle's right there. Yeah, you want my hoodie. I'm sure you want my hoodie. Forget that. So that's the convenience sampling. It can be okay, but it can also not be okay. All right, as far as scientifically sound. So here we've got an example. A professor wishes to know what students think of the cafeteria food on campus, and I really want to hear some opinions on this and tell me what you think is the problem here. Big problem. A professor wishes to know what students think of the cafeteria food on campus. So she distributes a survey to students in the cafeteria during lunchtime, asking them to rank the food from 1 to 5. 1 being poor, 5 being great, based on the variety of different criteria. Now, this is what we call a convenience sampling. The professor, all she had to do was print off some papers there from the photocopy room and then walk down the hall to the cafeteria from 12 until 12:50. And yeah, she did. Did she really do a scientifically sound study? And okay, the people, you have to think the people that are in there during lunchtime, have that class free, or they're in there during their time off. Maybe some students are working during lunch, doing extracurricular, maybe playing volleyball on the maybe away on a school trip. Okay, you've also got the idea there that if people are in there from 12 to 1 eating their lunch, eating cafeteria food, well, they're probably okay with the food generally, because it's their school and they've heard about it. It's not like it's a new restaurant that opened and it's a Michelin star. It's just a cafeteria. What about all the people who are not here? Where are they? Where are they eating? Why aren't they eating here? There's too many unsolved questions there to even attempt this. Okay, so this is an example of convenience sampling that doesn't work. Okay. Okay, so you guys can have a look at these, and these are really, and that's what the homework all is. Here, we'll try one. A teacher is interested in estimating the proportion of students who bring a packed lunch to school. A list of names of all 400 students in the school is available. 40 students are randomly selected from the list using a random number generator. Okay, simple random sample. That's what's going on there. Okay, if you guys have a read of this here, you will see there that it's a multi-stage, which I just changed. There we go. So try these out, and you'll see that they are wordy. That's the way these questions are, and we can't get around it because there's a lot of information in here that needs to be critically analyzed. And I don't want the English to be a problem. So if anything is bothering you, you just let me know. Because I try and write these things, I try and make these things, with your brains, what I mean, you in mind, the student learning. But sometimes I miss the boat completely. So just let me know. All right. What do we got here? When researchers desire to know the value of a particular variable, okay, they make use of a study. And there are 3 kinds of studies there that we'll be utilizing over the course of the next 13 weeks. There's an experimental study where we make a hypothesis. And a hypothesis is just an educated guess. Okay, I've got this pen here, and I'm going to drop the pen. And I think it's going to go up. I think that gust of air, I think it's going to go up. All right? That's my hypothesis. That's what I think. Okay? It went down. And you might think that, hey, my hypothesis was wrong. There is no wrong. There is only truth. So you see, I just proved that the pen went down. Now it just leads to further questions, right? Why did the pen go down? Further testing, further study. So an experiment, you're testing a hypothesis. An observational study, where this is more sociological, behavior. You look at Jane Goodall there, studied the apes there in Central Africa. Okay, the observer is not involved. The experiment is happening right now. I'm watching the children there, and I'm watching their behavior, or the whatever you're watching and recording. All right, you're not involved in the study. You're just watching it. It's interpretational. It's opinionated. Hopefully, it's video recorded so that other people can see its scientific validity. Okay, it's observational study. Surveys and census. Okay, there's the Canada Census going on here. It's just a survey that's been sent out to everybody. You send it back. Numbers are tabulated. Just involved there for different services in your area. The federal government does this there to find out if we need a school here or a hospital here. Maybe there's an urban development that wasn't here a year ago. A new housing complex. And we need to get in some social infrastructure there. So that's why we do these kinds of things, okay? Where are we here? Here's an example of an experimental study, okay? It involves manipulating of the particular variable. And this is one of the things here. We're going to get into, where are my, this is where I want right here. An experiment. If I have a plant, let's say I have a tree and a certain amount of soil, okay? Plants need sunlight, they need water, they need good soil, they need shelter, they need warmth, all these kinds of things, right? So what happens if I use the same plant and same soil, same sun, but then I change the temperature? So what I've done is I've changed something. That variable that you altered, we call this the independent variable. Whatever you change for your experiment, that's your independent variable. The outcome of that change, we call the dependent variable. So you have an experiment, and you've got all these things going on here. Okay, now we're going to lower the amount of water for this plant. And now you wait a week or two, your experiment is ongoing, and then you see there that the tree starts to wilt because it doesn't have any water. There is your dependent variable. Cause and effect. At least we hope so. We turned down the water for that plant. The plant a week later started to wilt. Okay, and it got very sick and almost died. That's the dependent variable. But the whole trick of the game is, when I turned down the water, was that the cause of the tree wilting? That's the trouble. Was there another cause? Is there a bug infestation in the soil? All right, there could be other factors at play that cause the dependent variable, that cause the tree to wilt. And we call these ones confounding variables. That's the hardest part of doing an experiment, is proving what I altered caused this. That's the whole trick of the game. So there could be other confounding variables out there that cause the tree to wilt, and that's the whole trick of the game, is to eliminate these confounding variables. Okay? Observational studies here. This is where you're watching a subject. The benefit's easy to conduct. Okay, then an experiment for sure. It can have ethical issues. If you, as the observer, involve yourself with the observer or of the person being observed, but generally the observer stays out of it. Okay. Drawbacks: results are typically less scientific. It's more opinionated, and it's much harder to control the confounding variables in an observational study, because the observer is just observing. And if the observer sees a confounding variable or something happen in the situation there about the person that they're watching, they can't alter anything. Okay, and now you have opinions being involved. Did this person do that for this reason, or was it this? Tough stuff sometimes. Survey, called a survey or a census, conducted there towards an entire population. Respondents are asked questions and are responsible for providing the information. Okay, and they're not too bad. Generally, there you get about 0.3% of respondents. So you send out, if you sent out 100 surveys, I don't even think you would get one back. I think if you sent out 1,000 surveys, I think you get 3 back. I think that's generally the statistic there. So it's a lot of wasted paper, but it's easy. All you got to do is lick stamps and lick envelopes and send them out. Here's some positive and minuses here. It's good for obtaining basic demographic information and learning about opinions there. Okay. Political views, for sure. They use this there for every election cycle. Drawbacks, it's not useful to learn about individuals, okay, in which individuals would tend to have biased. So, you know what I mean? It's good for some things, but you're not really going to get into a person's personal health because I'm not talking to you on the telephone, and I'm sure as heck not going to write it down in a census what's wrong with me. So this thing is going to go in the garbage. So, you know, that's how these ones go. And we've got some questions here. Identify the types of study being used in the following scenario. Y'all can have a read of this, okay, and go through. They'll just jump right out at you. So here we're just the 3 types of studies we did. We did observational study, we did a survey, and experimental. Have a look at these here, and you'll see that they're really not that bad to pick out. Okay, like a clothing company wants to find out who their biggest competitor is this year. Questionnaires are mailed out to their customers. Well, what kind of study is this? Bang. Okay, so that's how she's going to go. Have a look at those when you get a chance. They're not too bad. Errors, regardless of type of sampling methods chosen, results from a sample are unlikely to exactly reflect results of the entire population. Okay. Statisticians, mathematicians do understand that when we take a representative sample from a population, it's not going to be 100% accurate. So there's going to be, you'll see there during the election year, there's a 2% margin of error. You know, 33% of the people will vote conservative with a 2% margin of error. So what that means is there's actually a 4%, 2% on this side, so it could be 35% all the way down to 31. There's a little bit of statistical error there. We'll get into that there later on. Types of variables. There are quantitative, quantity, how much, and qualitative, quality. Okay, here we're talking about an ideology. We're not talking about numbers. We're talking quality. Okay, we'll get into all these kinds of things here. We'll start off there with quantitative variables. These are things that can be measured or counted. Okay, and these can be broken into 2. Continuous variable or a discrete variable. Oh yeah, know these ones here. Everything here, there today, you'll see again for sure. So when we're dealing with quantitative variables, there are two categories that this can be broken down into. Quantitative variables can be broken down into continuous and discrete. Continuous, I'll give you examples. Length, weight, time, temperature are all examples of continuous, okay? Because length. This pen here is 8.3 centimeters. This pencil over here, this remote control is 9.2. You see how there's no gap? You can have 1.375. You can have 5.5, 5.6, 5.7, all the way to a million, a billion, infinity. All right? It's just, it's numbers. You can... 212.5 pounds. You know, there's no limit to the amount of decimal places. This is what we call a continuous variable. Okay, time, you can have 1 second, 5 second, 10 second, 1.25 second, 3 hours kind of a thing. Continuous means there's no gap in the number system. A discrete variable. Have a look at this one. The number of people on a bus. You can't have 1.25 people. Okay, you can't do it. Right? So you only get 1 person or 2 people, or there was 3 people on the bus. There sure as heck wasn't 3.5 people on the bus. All right, so it's distinct or discrete number groups, 1, 2, 3, 4, that kind of a thing. The number of cookies in a jar. Well, you could see you can't really have 5.25 cookies, right? You can, but generally we talk about cookies as whole numbers, 1, 2, 3, 4. The number of books on a shelf. Doesn't matter if you have a little pamphlet duotang and then you have a big thick encyclopedia or dictionary. That's a book. That's a book. Okay? So you can still count them. Everything here you can count. But for a continuous variable, like temperature, it can be 25.0 degrees and then 2 minutes later it can be 25.6. It's continuous. And discrete, there's only certain numbers that can be used, but they still can be counted. Qualitative. These are things that can't be measured. They have some type, I'll show you here. Brand of jeans. So you have Guess, you have Buffalo, you have Levi. But you know what I mean? What is Levi better than Buffalo? Is Guess, how do you compare these? You can't. They're just different groups. You don't compare them, one is better than the other, but they're just groups. Types of bread. Brown bread, white bread, bread with nuts, gluten-free bread, rice bread, all these kinds of breads, right? They're just different categories. It's a qualitative idea. Genres of books. You have horror stories and you have romance. One's not better than the other. You can't compare them. They're just qualitatively different ideas. Okay? So these are qualitative variables. Identify the following variables as quantitative or qualitative. Okay? And if they're quantitative, classify them as continuous or discrete. So, Byrne classification. 1, 2, 3, 4. Right? Slight, moderate, intense, severe. Well, these are qualitative. This is opinionated. Okay? The number of people who flew to Toronto Pearson Airport there today. Discrete, quantitative. Counting number of people. Can't have half the people. Okay? The amount of time a teacher spends marking homework. Continuous, quantitative. Time. And the nice thing is about these, I want you guys to incorporate this into your mental repertoire. You know what I mean? You guys, I'm sure I got my vet techs out there. I've got my nurses, my RNs, my RPNs. I've got my firefighters and my paramedics. But don't stop there. Go on, do a bachelor. Go on, do a master's degree. Go on, take this information with you. Because this is good stuff. Master's degrees, they deal with this stuff there when you're doing a study. Bachelors, you guys, we all do these kinds of things here, man. So go on. This is not beyond you guys. This is right in your wheelhouse. Okay? A person's eye color, qualitative. Okay, quality. Okay, brown, blue, green. You can't compare these guys. And this is basically the end of the yeehaw. A little long there because I went into a little spiel at the start. But levels of measurement. The level of measurement of a variable indicates what limitations, if any, exist in how the variable can be analyzed. What does that mean? Well, there are 4 levels of measurement. And I want you to write down the word noir. It's black for French. French for black. And you'll see here, that's how I remember these. That's how I tell all my peeps how to remember these. You've got nominal. You've got ordinal. You've got interval. And you've got ratio. Okay? And you'll see how these ones work here, and I'll show you. Okay? These are the 4 levels of measurement that can be used to categorize data. What kind of data am I dealing with? Well, the first one, nominal. There is no specific order. There's no interval between measurements are not meaningful, and there is no zero. So you have a look here. Gender, religion, country of birth. There's no order. like France is, or Canada is before France, other than alphabetical. You can't compare these things. Gender, religion, they're just distinct categories. No number system, no zero. Okay, that's called nominal. Ordinal, again, there's no zero. Okay, but there is some type of a hierarchy. This one here actually has more meaning than this one here. And the third, and I'll show you here, star rating. Like you go to Rotten Tomatoes there and you see a movie there, it's got 3 stars. Well, what's the measurement between 1 star and 2 star? There isn't one. I just liked it more. Well, if you give something 3 stars, is it actually double what somebody or triple what somebody gave 1 star? No, there's no rational reason. It just means I liked it more. GPA, you can't compare GPA from one course to another. These kinds of things. It's qualitative data that is usually specified using letters or symbols. Okay, like a star rating. You go on Expedia, and this hotel is a 5-star. What makes it that? Yeah, be careful when you go on holiday and you see a 5-star. Generally, a 5-star ain't a 5-star. So that's a good one there. So we've covered nominal and ordinal. So ordinal is kind of the same as nominal, but here there is a little bit of a hierarchy. There is a ranking. Nominal, there isn't. Interval. Let's have a look at the examples. Temperature, dates, years. So they're ordered by relative position. So there is an order here, and it's a clear order. Temperature goes up by 1 degree Celsius from 22 to 23 to 24. There is a distinct system going on here that is measurable. Years, 365 days. Okay, so there is a system at play here. Okay, but there is no zero. So here, when we're talking about, the dates, year, date of birth, all these kinds of, there isn't really a zero. It's when were you born? 1972. When were you born? 1989. These kinds of things, right? It's just there is a space in between each number, and it's measurable, but that's really not the point of what this is. What's the temperature like here as compared to Dallas, Texas? Well, here it's currently 23 degrees. In Dallas, Texas, it's 37 degrees. Oh, okay. All right. And by the way, 0 degrees Celsius isn't 0. 0 degrees Kelvin is 0. You guys should be on that pretty well. If you have any issues with Kelvin, come talk to me. What do we got here? We're almost at the end. You're almost there. Congratulations. And the last one here for the levels of measurement is ratio. This is the only one that has a meaningful 0. C'est bon? Got it? This one here is kind of related to interval, where there is a definite ordering. There is a pattern, mathematically sound, and here there is a 0. And here we're talking about percentage. I got a class average was 75%. Or this student here got 85%. Okay? And speed, weight, these kinds of things. So there is your noir. Nominal, ordinal, interval, and ratio. And again, there's lots of questions here there that y'all can go over and have a look at. Every single question I've given you, you've got answers for. So I think you guys are on top of things. What do we got here? There's more questions here. Which sampling method would be most appropriate for a study on passenger satisfaction for a new subway train in Toronto? Well, you think about this. Remember that convenience sampling? Remember that lazy professor there who wanted to know about if the cafeteria is good? Well, she only studied the people who were in the cafeteria. Well, you know what? Maybe that didn't work for the cafeteria because maybe there was all these people outside the cafeteria that hated the food, and I'm not going there, so I'm not going to be a part of your survey. But look at this one here. If we're looking to make upgrades there to the Toronto TTC, the subway system there in Toronto, am I going to ask somebody who doesn't use the subway? No. I'm only going to ask people who use the subway. So in this case here, a convenience sample would be appropriate. Have some fun with these. It should be fun. It's societal in its application and all that kind of stuff. So have some fun with this. That's what I got there. I don't even know. Is there anybody still here? Oh, there are. There's, oh, man, it's pretty good. But I'm going to stop recording now. I hope you guys are good. If it's as clear as mud, go and take a break. Come back to it. The video will be posted. Have a look at it. Try the questions there in the back. And I think you guys will just be rockets. All right, how we doing? We okay? Get out of here and enjoy your day. Thanks, guys.
I have a question.
Yeah. Just hold on before. Give me 2 seconds here. Sorry, Cheryl. If anyone has any questions, stick around after. I'm not going anywhere for a little while anyway, so stick around if you have questions. Go ahead, Cheryl.
I'm just wondering where you're going to